guys, welcome back to my channel. In this lesson, we'll be discussing sketching of quadratic graphs from the expanded form and also from the completed square. So let's start the sketching from the expanded form. So let's do part A first. This is a quadratic expression whose coefficient of x square is a positive value, which is 1. Now that would mean that the graph will be it will look like this. It's a parabola. And in the second case, where the expression is minus x square, that means the graph is going to be an upside down graph, an inverted parabola. So this is the first thing you should check, whether your graph has a coefficient, whether your equation or the expression has a positive coefficient of x square, like in this case, or a negative coefficient of x square, like in this case. So we're going to do the first one. Okay, now this value here gives the y-intercept. This is the y-intercept. The constant in the expanded form is always the y-intercept, that is where the graph cuts the y-axis. So here the graph will pass through minus 4. Okay, now I need the x-intercepts. So for that, I'll solve the quadratic equation. So x square minus 3x minus 4 is equals to 0. I'll use factorization in this case. So x square minus 4x plus x minus 4 equals 0. X is common, x minus 4, and then plus 1 is common, x minus 4 equals 0. So the factorized form is this, which gives us the two roots of the equation, x is equals to 4 and x is equals to minus 1. Now these two are the y-intercepts of the graph. That is where the graph, sorry, x-intercepts, where the graph cuts the x-axis. So this graph is going to cut the x-axis at minus 1 and then 1, 2, 3, 4, roughly over here. So the graph will pass through, it'll pass through here, it'll pass through here, and it'll pass through here. So next thing I should know is the turning point. Where will the graph turn? So what's going to be the turning point? The turning point is going to be in this value basically. So how do I find the turning point? The x coordinate is just the midpoint of minus 1 and 4. So this value. So what's the x value at the turning point? Minus 1 plus 4 divided by 2. So that's 3 divided by 2, which is 1.5. So the value of x here is 1.5. And now I need the value of y. So for y, what I'll do, I'll simply substitute this 1.5 in this equation. So let me do that over here. So 1.5 square minus 3 times 1.5 minus 4. So that's going to be 1.5 square minus 3 times 1.5 minus 4 gives minus 6.25. So the value here is minus 6.25. You need to write minus 6.25 over here. Now you might not be asked to find the coordinates of turning point. Then it would be just good enough to make a graph like this. There's no need to find the turning point. But if you're asked to find the turning point as well, then you find it by the method that I just showed you. So this is part A of sketching a graph from an expanded form. Now let's do part B. Okay. So for part B, let me quickly sketch a grid. This is the y-intercept, which is 15. So the graph is going to cut the y-axis at 15. Let's say this is 15. All right, now I need the x-intercept. So let's equate this to 0. Minus x square plus 2x plus 15 equals 0. So the factors could be minus 5 plus 5x minus 3x and then plus 15 equals 0. If x is common in the first two, so minus x plus 5, and then I'll have to take 3 common in the next two, so minus x plus 5 equals 0. So x plus 3 minus x plus 5 equals 0. From here we're getting x equals to minus 3, and from here we're getting x equals 5. Now these are the two coordinates of the two values of the x-intercept. So the graph cuts the x-axis at minus 3 and at 5, so roughly over here. So the graph looks somewhat like this. Now if you're asked to find the coordinates of the turning point as well, so for that what you do, you first find the midpoint of minus 3 and 5. What is that going to be? Minus 3 plus 5 divided by 2 is just 1. So the graph will bend at x equals 1. So let's write x equals 1 over here. Now when x is 1, let's substitute the values in this expression. So it's going to be 15 plus 2 times 1 minus 1. So that's 16. So this value here would be 16, where the graph will peak. So that is how you draw the graph of part B. And now you might be asked to find the line of symmetry as well. So line of symmetry is just this line that cuts the graph into two equal overlapping parts. It passes through x equals 1. So its equation is x equals 1 as well. So if you're asked to find the line of symmetry, that's x is equals to 1. If you're asked to find the turning point from here as well, so that is 1, 60. Okay, now let's do sketching graph from completed square form. All right, so this is the question. We have to sketch the graph of fx where fx is in completed square form. So the first thing you should do is state the turning point of the graph. So this is the turning point of the graph, or this is the turning point of the graph, depending if it's parabola or inverted parabola. So the turning point is always found by equating this to 0. So x is equals to 1.5. So the first value of the turning point is 1.5, and its y's value is this value itself. So that's 0.5. So what did I do? I equated it to 0 and I got x is equals to 1.5, and then I just copied this value over here. So this is the turning point of the graph. So if I roughly sketch the graph, let's say 1.5 is here and 0.5 is here. So that's the turning point. And since the coefficient of x square is 2, when you expand this, you'll get 2x square. So it's going to be a parabola shaped graph. So this graph is going to go like this. Now you would also need the coordinate of this y-intercept. How would you find that coordinate? You can simply equate 0 in fx. So when x is 0, look, x is 0 over here. So when x is 0, what's the value of y? 2 times 0 minus 1.5 square plus 0.5. So that would be 2 times 1.5 square plus 0.5. That gives 5. So this value here is 5. So that's the sketch from a completed square form. Okay, let's do another example. So now we have to sketch the graph of this. Again, let's start with the turning point. That's found by equating x minus 4 to 0. That gives x is equals to 4. So 4 is the x coordinate of the turning point, and the y coordinate is just this value outside the bracket with its same sign. So that's plus 50. So this would be the turning point of the graph. Let's say we have 4 here and 50 here. So that's the turning point of the graph. Now, is the graph going to look like this, or is the graph going to look like this? So for that, I'll need to take a look at the coefficient of x square. So when you expand this entire thing, we see that the coefficient of x square will be negative 2x square. That means it's going to be an inverted parabola. So the graph would be like this, or maybe like this, I'm not sure. I'll need to find the y-intercept first. So what's the y-intercept? How do we find y-intercept? By substituting 0 in place of x. 50 minus 2 times 0 minus 4 whole square. So that's 50 minus 2 times 16, that's 18. So that means this is the y-intercept somewhere over here, and this is what the sketch would look like. So yeah, that's about it. So that's how you sketch the graph of a quadratic expression that is in completed square form. All right, I'll see you next time with another video. Bye.